Welcome to this series of introductory lessons related to the time value of money. My name is Brent Pritchard. I teach college finance courses, and I'm here to help you grasp this all-important concept. This introductory series is designed to help you learn how to apply the mathematics of finance in less than a month, provided you commit to one or more lessons a day. It's that easy. Acquiring the hard skill that is the mathematics of finance doesn't need to be hard. I hope you enjoy this fun new take on this age-old concept. And after you've done that, please consider telling your friends about this channel, TVM Rules, and the book, Would Your Boomerang Return, also known as the Boomerang Book, that made it possible. Okay, I like to start every class with a quote. Here's the quote of the lesson. Work hard to develop relationships and do what you say you are going to do. Those were wise words from Jim Sellers. Now, I'm going to pause here for a little bit and tell you a short story. Jim was a great man. He's no longer with us. I worked with Jim for 22 years to the day when I worked in commercial real estate. Everybody loved Jim. He was a friend of many. And one year we found ourselves at a conference for the commercial real estate industry. And we were at a party and we were at a table, and the party was clearing out, and I thought, I'm going to pick this guy's brain. We'd been friends for a while. And so I asked Jim, can you help me understand, how have you done it? How have you been so successful over your career? And he paused, which I was so grateful that he did, because he gave it a lot of thought. And after a couple seconds, he provided these great words of wisdom. Work hard to develop relationships and do what you say you're going to do. Man, that's true. And in fact, on my bookshelf behind me, I've got Jim's business card, and on the back of it is this quote. As soon as he gave me this quote, I turned his business card around, I wrote it down. I didn't want to forget it. So these are exactly the words that Jim spoke that day. I mentioned he's no longer with us. God rest his soul. Jim was a great, great man. Okay, on to the lesson. Do you want to know the good news or the bad news? Now, there's really no bad news here, but I'm going to start with what some might think is bad news. You need to memorize the building block time value of money equations. Why, you might ask? Well, to double check your work. Now, the good news is there are 9 building block time value of money equations. You can count them on 2 hands. If the idea of memorizing 9 building block equations scares you, then I've got great news. You really only need to know 5 of the building block equations. Why only 5? Do you remember my Post-it note story? There was a reason why Mike Trotter didn't need another Post-it note to write out the building block present value equation. This is because the building block future value equation can be rearranged using algebra to reveal the building block present value equation. In other words, the building block present value equation is hidden in the building block future value equation. Second, because of what I call the flux capacitor of finance, the mathematical expression 1 plus I in parentheses raised to the power of n, and that's uppercase N. This is the mathematical expression that permits time travel in the context of the mathematics of finance. Hence the name, the flux capacitor of finance. This one mathematical expression, or more precisely, 1 plus I in parentheses, or what I like to call the add-on expression, is the other thing that differentiates the mountain, the 9 building block time value of money equations, from the molehill, the 5 fundamental building block time value of money equations. So let's go through them. Before we do that, I just want to note that I've done a little bit of prep work prior to hitting the record button to save you from having to watch what would amount to my coloring on this slide. So here's how we interpret these equations. For the new equation, the new color shows what's different from the last equation. So we start with the building block future value equation at the top, and we work down to the building block true investment yield equation at the bottom of this slide. The building block true investment yield equation, it's not only the most unique of all the building block time value of money equations, but arguably the most important. So as we go through the 9 building block time value of money equations, notice how I, lowercase I, the true investment yield, shows up in every one of them. Okay, I'm going to riff on this slide for a little bit. So we start with the building block future value equation. That's in all black. We move on to the future value of an ordinary annuity. Let's talk a little bit about the difference between PV payment and PMT payment. We've talked about this in prior lessons. I'm sure we're going to talk about this in future lessons. But let's talk about the difference between PV payment and PMT payment. PV represents a single or lump sum payment. I've mentioned before that, that word payment can carry a negative connotation, but here it means a deposit or an investment or a withdrawal or a receipt of cash. That's what payment means in the context of the time value of money and the mathematics of finance. So PV represents a single or lump sum payment. A PMT payment, on the other hand, represents an annuity. So a payment series that has level or even payments in terms of amount and timing. Okay, so let's talk about the timing of the future value of an ordinary annuity. That's the next thing that we need to touch on. So we've moved on to the second equation. See what's new. It's in blue. I like how that rhymes, but it's true. That's not by design, but I like how it worked out. And when we look at the future value of an ordinary annuity equation, we see, well, really not much is new when we understand that there's a PV payment and a PMT payment, and I guess also an FV payment. But what's new here is in blue. But the timing of that value, the future value, is as of the last payment in the series. Now that's really important. I'm going to say it again. For an ordinary annuity, the future value of an ordinary annuity, the value is as of the timing of the last payment in the series. Okay, let's move on to the next one. PVOA, what does that stand for? Well, it's short for present value of an ordinary annuity. You see what's new here in, what is that, orange, yellow? It's not as orange as my shirt, but I think it's orange or yellow. Maybe it's gold. But we see what's new here in that color. And again, when we start with the future value equation, we progress to the future value of an ordinary annuity equation, and then we move on to the present value of an ordinary annuity equation. I mean, this is by design because you can see that not much is different between the present value of an ordinary annuity equation and the future value of an ordinary annuity equation. Let's talk about timing. Again, we're talking about an annuity, so we're talking about a payment series with even or level amount and timing. But for the present value of an ordinary annuity, the present value is as of one period before the first payment in this series. Again, it's so important, so I'm going to repeat it. The present value is as of one period before the first payment in the series. Moving on. PVOP is short for the present value of an ordinary perpetuity. A perpetuity has a payment series that is believed to be infinite, so with no end. And you see what's new here in red. Now, let's focus first on the denominator. That's I underlined, so the true investment yield underlined, where I underline equals I, the true investment yield, minus the growth rate. So sometimes you're going to have a payment that has constant or even growth, maybe at 3%. And when you've got constant growth, that's the input for G. So I'll put some numbers to this. Let's say that the true investment yield, you're dealing with an annual payment for this perpetuity, and the true investment yield that you're working with was a true annual investment yield of 12%. And the payment, the first payment was $100,000, and it was going to grow at 3% per year in perpetuity. So G would take the value of 0.03. So one underlined in this example would be, did I say 12% before? I hope I did. 0.12 minus 0.03. So one underlined would be 0.09 or 9%. So that's how the math works. And then last but not least, we've got the building block true investment yield equation. This is really important. I mentioned how it's unique. Take a look at it. It has all lowercase variables. That's one of the ways that it's unique. But I is so important. Whether you're double checking your work with these building block time value of money equations, which is really important to do, or at least to be able to know how to do, or you're plugging numbers in your financial calculator, you need lowercase I. You need to know the true investment yield. Now, some other people are going to call this lowercase r. That's not me. I believe in consistency and simplicity, and all of that is described in the book and beyond, and we're trying to do that here as well. So I refer to the true investment yield with the variable lowercase I. Let's move on to the next slide. So these building block equations are for annuities. A perpetuity is just an annuity on quote unquote steroids, since the payment is believed to never end. And so these equations were copied over from the last slide. I wanted to make sure that they show up in all black because there's going to be something new here. Hint, 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 the add-on expression. So with the add-on expression, we turn these building block ordinary annuity equations, the perpetuity is just an annuity on steroids, into the annuity due variety. And so I'm going to show you how we do this. Let me turn my tablet on. I think it fell asleep on me. And I'm going to pick a new color. And this color is going to be a brownish red times the add-on expression times the add-on expression. And what this add-on expression does is it moves the value one period to the right on the timeline, or under the timeline. That's how I teach it. And when we add on this add-on expression to these three equations, here's what we get. The future value of an annuity due, the present value of an annuity due, and the present value of a perpetuity due. So let's talk about this for a little bit. And let's talk about timing. So for the future value of an annuity due, this first equation will give you a future value as of one period beyond the last payment in the series. Again, the future value timing for the future value of an annuity due equation is as of one period beyond the timing of the last payment. Moving on to the present value of an annuity due equation. The timing for this present value is as of the first payment in the series. Remember, for a present value of an ordinary annuity, the timing of that present value is as of one period before the first payment in the series. Here, with a present value of an annuity due, the timing of that present value is as of the timing of the first payment in the series. And the same thing for the present value of a perpetuity due. The timing is as of that first payment in that perpetual payment series. Okay, so we have one more to go. And I'm going to switch the color to black because this is where we started. And we've got the present value equation. Present value equals future value over 1 plus I raised to the power of n, and that's uppercase N. That rounds out the 9 building block time value of money equations. Now, but for the building block true investment yield equation, do you see how we really just have present value equations and future value equations? That's really what we have here. Present value equations and future value equations for lump sum amounts and for amounts that are even or level in terms of amount and timing. And then with respect to the present value of an ordinary perpetuity or present value of a perpetuity due, we've added in this idea of constant growth. So you may have constant growth for that payment. And that makes sense because we're talking about a payment that is believed to continue in perpetuity, and that's a long time. So let's move on. I got a real world situation for you. Take some time to read through this slide. I guess you can't take the commercial real estate professional out of me. It's still in me. And so this is a real world example. This is the kind of thing that you would analyze if you were a commercial real estate professional. TIs, or tenant improvement allowances, are quite common. And this is the setup. So let's move on to working this out. I'm going to draw the TVM wallet. I think in the last video, I'm pretty sure I called it the TMV wallet, but we know it's the TVM wallet, but what are you going to do? You know, when these videos are raw and uncut in the style in which I teach, sometimes you make minor mistakes like that, but you know what I'm talking about. Okay, so we're going to draw the TVM wallet. We're actually going to draw two TVM wallets, and I'm going to stack them right on top of each other. It kind of looks like that FBI wallet, you know, if you ever watch the X-Files where Fox Mulder flashes his wallet, or Dana Scully flashes her wallet. And so we're going to draw two TVM wallets, one right on top of each other. There's our fill in the blank for the subscript. PV, PMT payment, future value. So we're going to work with the first wallet from the top. I'm going to talk about this in another unit. I've written about this before multiple times, but the way that I teach the time value of money, I repeat, I do not support begin mode in your financial calculator. There are a couple reasons for this. First, it's really easy to forget to switch back to end mode. And second, if you forget to switch back to end mode, that's like being one question off on a standardized test, and when has that ever been good? So I do not advocate for begin mode. Far from it. In fact, on my calculator, I scratch out begin mode. I never use it. And so when you don't use begin mode, like me, you've got to take an extra step when it comes to answering a real world situation like this one. And I'm going to show you what I mean. So in this case, the future value is $15 million because we need to figure out the value as of time period -1 on this timeline. Yes, that's a thing. You can add real estate to the leftmost side of the timeline. And so here we've got $15 million. We're trying to solve for PV, and I'm going to put a square or a rectangle around that because it's the first step. It's not what we're ultimately solving for. We're telling time here monthly, so we know that only a true monthly investment yield is going to work. So I'm going to fill in the subscript there with M for months. And we are solving for PV. So there's one period between 0 on this timeline and -1, the -1 time period marker. Up here, I'm going to solve for the true monthly investment yield. So in the prior slide, we were told that the simple or nominal annual investment yield is 7.5%. So this is that in decimal form. We were also told that compounding happens monthly, or that's what we were to assume. This is just the building block true investment yield equation. So what we have in parentheses here is a simple monthly investment yield. After we divide a simple annual investment yield by 12, we're left with a simple monthly investment yield. And since we're telling time with months on this timeline, lowercase n takes the value of 1. And when we subtract 1, we get I, which is 0.00625, or 625%, which is a true monthly investment yield. In my calculator, I need to input that as a percentage. So that's why I'm going to redo that 5. There we go. That looks better. And when we do that, we solve for present value. 14,906,832 and what is it? 30 cents. So that's step 1. So we've completed the first TVM, not TMV, TVM wallet, and now we move on to the second wallet. We still have our -1. I kind of like the dotted line there because it's a little atypical, but it is a thing. So this is still a month. So only a true monthly investment yield is going to work. And we've got that already. It doesn't change on us. So we're still telling time monthly. PV, PMT, future value. Okay. So we've got our present value as of time period -1. So we're going to put that here. It's going to be a little cramped, but I'll try to write small. 14,906,832.30. Okay. And we want to know what is the additional payment that needs to be charged. So I'm going to circle that. What's the additional rent that needs to be charged for this proposed lease? N takes the value of 36 because there are 36 payments in this series. We've got our PV, that's -14 million. We just copy this over from the first wallet, 832.30. And we solve for the payment, the even payment. And the payment is $463,695.18. There we go. That's the answer. Now, why did I pick this real world question? You might be asking. Well, even if you're not asking, I want to tell you because it's kind of fun. I don't know if it's fun, but it's real life. It wasn't until recently that one of my students got this right, and I actually went back and counted how many students got it wrong before this student, just because I was curious. He was the 121st student. He got it right. 120 people before him got it wrong. True story. And I'd like to believe that if more people knew how to double check their work with building block time value of money equations, that right answer would have come sooner. So I'm going to show you how to double check your work here. I'm going to draw a timeline first. 0, 1. Remember, rent is paid typically in advance as opposed to in arrears like a mortgage payment. And you were given that information in this real world situation. And so the payment starts right here at the beginning of the lease. And then this is the beginning. 35 on this timeline represents the beginning of the last lease month. And so that's what we're solving for. Remember, the present value of an annuity due, that's as of the timing of the first payment in the series. It kind of rolls off the tongue, doesn't it? So we use the present value of an annuity due equation times it really doesn't take that much to memorize these. 1 plus I raised to the nth, that's big N, times, that's I, times 1. This is the add-on expression. So the future value, rather the present value of an annuity due, this is that amount right here. This is what it's going to cost to make ready the space for this prospective user. And so this is our present value of an annuity due. So I'm going to write out what we have here. We're solving for payment. Times 1 plus 0.0625. I'm kind of writing on top of the circle there, but that's okay. 1.00. Remember, we got to use the decimal form. 625 raised to the power of uppercase N, 36, minus 1. Same thing down here in the denominator. 625 raised to the power of 36 times 0.00625. So there's a relationship between uppercase N, 36 in this example, and PMT payment. There are 36 PMT payments. So working this down, equals payment times, for all this right here, I get 32.3488. That'll do. And then when we move this to the other side and put it under $15 million, we get payment equals $463,695.18. There it is. We can circle it. That's our payment amount. So it's really important to be able to double check our work. That's why we do this. Financial calculators, they're great. They can also be a little bit of a crutch. And we've got to learn to walk before we run. And that's why we learn how to do the math before plugging the math. Okay, that's a wrap. So if you like what you learned in this lesson, please consider telling your friends about this channel, TVM Rules, and the book that made it possible. Believe it or not, like I told you, it took 121 students analyzing this real world time value of money situation before someone got the right answer. I want you to think about that for a little bit longer. It pays to be able to double check your work rather than just showing someone a calculator and say, here's the right answer. How do we know if it's the right answer? I want you to be able to know if it's the right answer. So if you haven't purchased your copy yet, all the important information on this all-important topic is gift wrapped within the cover of Would Your Boomerang Return? Until next time, enjoy the gift that is the present.